Desktop personal fabrication has exploded over the past few years. It's not just 3D printing, but also desktop CNC systems and laser systems. This opens the door to the idea of custom printed parts in our homes, reduced inventory and distribution centers, and fascinating new projects coming from everywhere, including school kids and startup entrepreneurs. Today, we're talking to John Kawola, president of Ultimaker North America, maker of one of the most respected 3D printers on the market. Stay tuned because we'll be diving deep into the future of 3D printing. So, hey, John, welcome. Thank you for joining us.
Yes, good afternoon, David. It's a pleasure to be here.
So, let's get started really diving right into the future of this. What I'm trying to do is get a picture of the blue sky of where we're going to be in 10 or 20 years. Clearly, we won't have Chief O'Brien's replicators, but help me envision the next 20 years. What's practical, what's on the cusp, and what surprises do we have in store?
Yeah, I think in thinking about the next 10 or 20 years, it's a little bit helpful to spend maybe 30 seconds talking about the last 20 years. So 3D printing's been around since about 1990, actually. First 3D printers came out in the 90s. These systems were hundreds of thousands of dollars, really only used for prototyping. And then the 2000 decade came this wave of printers that was tens of thousands of dollars, so maybe 40, 30, 40, $50,000. Still primarily only for prototyping, but it opened up the door. It wasn't just the biggest of companies, but now maybe some smaller companies could start doing it, and schools started doing 3D printing. And then starting around 2010, 2011, desktop printers show up for the first time. Or very early versions of things that were less than $5,000. There were a whole bunch of companies that came on the market. And so it's been interesting to see how there's been different changes, not only in the technology getting better and better and better, but the price going down. So the price going down pretty significant, almost in steps, I'll call it, over the last 25 or 30 years. So in thinking forward, I think the things that we get excited about are that really in two areas. I mean, lots of people have talked about a 3D printer on every engineer's desk and been talking about that for years. Even when the printer was hundreds of thousands of dollars, people were talking about, oh, you have one on everybody's desk, or tens of thousands of dollars. And even when it weighed 300 pounds to put it on somebody's desk, and that wasn't really practical. But that's starting to really happen now. The fact that desktop printers, you can pick them up, you can put them on your desk. And it's probably still true to say that they're not completely widely distributed throughout engineering organizations around the world. That's starting to happen, and it's starting to move from having a dedicated printer in the corner or behind glass where somebody has the key to where you have them. Maybe they're not on everybody's desk, but in an engineering organization or design organization where you may have 100 engineers, you might have 20 printers. And so I think that will continue to happen. Over the next we can see over the next 2, 5, 10 years that they'll be distributed in a way that they're really for personal use. I'm old enough to remember my first engineering job, and we all didn't have our own computer. We had to share a computer. Well, that's a little bit crazy today. everybody has a computer, but we could see that in 3D printing. And then the second part of that is the way 3D printing has moved really started to really move into manufacturing. I mean, the limits in the past were really two things. Parts weren't good enough, and cost too much. And both of those barriers are starting to come down, maybe not in steps. Maybe this is more of a continuous process where the economics of using a 3D printer for printing real parts is getting better and better and better, and getting closer to traditional methods for manufacturing. And then just that the quality of the part. If the part's not, doesn't closely approximate, or in some cases exactly approximate what the part needs to be for that real functional use, then it's not going to be considered. So I think those are the two things that I look forward to in the next 10 years, is a continuum of distributed use and really using these printers for manufacturing.
So do you see that being meaning that the prices are going to continue to drop even more, the barrier of entry prices, the material prices, that sort of stuff? Or do you see that it just becomes more useful over that time period?
Well, as a printer manufacturer, we do hesitate and hope that maybe the prices don't keep going down and down and down. It becomes more of a challenge as a company.
Right, right.
But certainly there'll be continued price pressure, oh, whether that's a good term or bad term. But for the customer, that's a good thing. There will be continued price pressure to make these more and more affordable. In manufacturing, especially, I think material prices will really start to come down as more companies enter the space. Some of the big respected chemical and plastic companies of the world who are only just now getting involved in 3D printing. They were shut out for a long time. That will drive prices down, I think, and make it more economical for production. So I think that's clearly a trend. On the equipment side, I think that'll still be a question. Will the prices come down, or will they stabilize and just become more and more useful to customers, and therefore, in some ways, more and more affordable if they're used for lots of different applications?
Yeah, a colleague and I were talking about the fact that a kilogram of filament costs less than a vial of printer ink.
Yeah,
And it's kind of interesting, and that brings us to the question of almost all printer inks are proprietary, or at least mostly proprietary, and yet we've seen tremendous pushback against those few 3D printer vendors who have proprietary filaments. Now you walk the middle line. You have smart filaments, but you can use any filament, and so you just make it easier, right?
yeah. I mean, we our core competency as a company is not necessarily the chemistry of the plastics. So we partner with a number of the big plastics companies for them to formulate and and make filament for us, and then we brand it and offer it to our customers. And we build things into the spool. We have a smart chip that allows it to integrate with the printer and makes that ease of use something that they really value. But our printers are also still what we'll call open platform. So people buy other filaments. They like to try other filaments. So you're right. We've walked sort of down the middle of this. We think for the customer, this is probably the best solution. They have the freedom to try lots of different things, but they also have a line of materials from us that we can certify as tested and optimized and really great for the printer itself. And so I think for the customer, that's the benefit. For us as a manufacturer, we have to try to walk that line. And we it's hard for us to know exactly what our market share of our filaments on our printers are, but we would estimate that it's on the order of 30 or 40%. And as long as we can build a good business around that, and we know there's lots of customers who buy our printers because it's open, I think we try to balance those things out and build our business around that.
That makes sense. So speaking of Ultimaker, you're very much in the middle of this market. What is the company's background? How did it get its start?
Yeah, the company started like a lot of the early desktop companies. There was a whole sort of wave of them. Maybe we can. I don't know if they were exactly the first, but this all probably started. Everybody remembers MakerBot.
Mm-hmm.
And MakerBot started in New York, and it is very much a maker project, and in a lot of ways a larger than life personality out there. They're pushing this idea, and there were lots of companies that were formed. And when I say companies were formed, lots of these were a couple guys, literally in their garage or their shop or their basement, who started a desktop 3D printer company. And Ultimaker was not much different than that. Really, the three of our founders founded the company in 2011 out of a makerspace in the Netherlands. They saw that there was an opportunity. They really liked what they were doing. They started building kits. People started buying those kits on the internet with their credit card, and that was the beginning of Ultimaker. And since that, so the company is now about 6 or 7 years old. We've evolved from that point into being something larger than three guys in their garage.
Yeah, definitely. So speaking of being larger than that, I'm fascinated by the Volkswagen story. I wrote about it when you first shared it, but can you give us both a 2-sentence overview about their use, and then tell us some other stories, with or without naming names, about how 3D printing has transformed business processes and turnaround times?
Yeah, so the Volkswagen story is an interesting story. So Volkswagen is right now it's actually the largest manufacturer of automobiles in the world. They have always used jigs and fixtures and tools on their production line. They've needed those. This is not something new, but they made them, and they made them other ways. They would machine them. They would contract out to get these parts made. And they found that using 3D printing was an interesting and a more convenient and a more low-cost way to make these fixtures on a regular basis. The other added benefit of using 3D printing is they found in the manufacturing process, they got lots of feedback from the factory floor, like this fixture would be better if, or if only you could change it this way. And so they found they had a live experiment about how to offer jigs and fixtures and tools from the manufacturing floor, but also have that real capability to tweak and change them every week or month, or depending on the car that's coming down the production line. And so again, I think what Volkswagen did is they made these before in different ways. They even made these before using more expensive 3D printing technologies. But then they found that having just a room full of desktop 3D printers gave them a lot more flexibility and at a much lower cost than what they were used to before.
So give me a couple of other examples.
Yeah, so it's a common thread that I think desktop 3D printing is experiencing right now. Not just Ultimaker, but some of our competitors in the marketplace. Is there when these printers first came on the market, they were perceived to be not really useful or not really good enough for most engineering or tooling or industrial applications. And if you go back a couple of years, that's probably true, right? I mean, you had printers that were made out of wood, you had printers that made plastic stuff, and it was probably correct that most people characterizing them as being only for the makers or only for the schools, but not really good. I'm a real engineer. These aren't good enough for me. But what has changed is they have gotten better and better and better in terms of reliability and part quality and material properties. And in some ways, I think us and our competitors have to credit our customers in a lot of ways trying these desktop 3D printers for the first time, and in some ways dragging us into some of these applications. Even the Volkswagen application, we didn't walk in there and say, you should do this for your jigs and fixtures and tools. We discovered it. I mean, they found it on their own and they tried it on their own because the cost of entry of getting a couple desktop 3D printers is low. Mm-hmm. So why don't we get a couple of these and try it out? And so there's numerous applications that we have where customers bought a 3D printer, perhaps just for visualization or prototype, and then they said, well, maybe we could use this for a jig or fixture tool. Oh, it's good enough for that. We didn't think it would be. It is. And even an extension of that, even for short run production of either some consumer products or some sort of valves and different nozzles for different types of industrial machines, are now being made on a $3,000 desktop printer. And we give our customers all the credit for sort of discovering that and trying that and making that work.
That's very cool. So what about you? Who is John Kawola? Am I pronouncing that right? And what's your role at Ultimaker?
Yeah, you are pronouncing it right. So I've actually been involved in 3D printing for a number of years. So we described earlier how 3D printing started back in the 90s. We'll call that 1.0. And then 3D printing 2.0 was in the 2000 decade. And I was involved with a company called Z Corporation, which was a wave of 3D printing companies that came out. This is when they were tens of thousands of dollars. And we built that company over time, and we sold to, our sales argument at that time is the same as the sales argument with Ultimaker. These are for faster design times and better decision making and fewer mistakes, and a lot of the real value proposition of the 3D printer. We built that company up over time. That was a nice success. Actually went away for a couple of years and was in the robotics space, but was always watching the desktop wave a little bit from afar, and became convinced that yes, this is going to be disruptive. This is another wave, and got involved with Ultimaker about 2 years ago. And so my role here is to help Ultimaker really globalize its business. Ultimaker is a Dutch company based near Amsterdam. So we started in earnest a real U.S. operation in 2015 and 2016. So we opened offices here in the States. I'm based here in Boston and Cambridge. We have an office in New York. We have people spread around the country. We actually manufacture all Ultimaker products for North America in Memphis. And so that's been my role here, is to help us sort of serve this part of the world.
Cool. So let's talk about where Ultimaker fits in this market. Ultimaker is kind of at the higher priced end of the personal fabricators. What do you think of all the market pressures pushing pricing down. Do you think there's a role for the sub $200 machines, the CR10s of the world at about $500, and your machines, which are what, about $3,000 and up?
That's right. Um, yes, I certainly I think there's a role for all those different layers. I think, and that sort of separation of the desktop market has only maybe happened in the last year or two. I think that all the desktop printers were sort of bundled together at one point, and then we've got the low cost offerings, and then the higher cost offerings that we're generally in that category. Yeah, so we see that for the lower priced printers, there's certainly education. There's certainly personal use, people getting involved in 3D printing and trying to learn and do things. And as price moves up, typically as price moves up, capability moves up, the range of materials that you can use, perhaps ease of use continues to move up. And so at least at present, we think the family of machines, us and our competitors that are in that sort of $3,000 to $5,000 range, have a level of capability and ease of use that best serves the professional user, and the ones that are lower price probably best serves the personal user or the school. But I also, coming from where I came from, I think nobody would have said that a $3,000 printer could do what a $30,000 printer could do
Mm-hmm.
a few years ago. So I think we're not naive to think that a $500 printer can't do what an Ultimaker can do today. And so I think we'll just have to be conscious of that and try to manage our business the best way we can.
It's kind of interesting because the photo printing market went through a similar change. I had a piece of photo software back in the late 1980s, and back at that time, to be able to display a JPEG, you needed a special card you put into the machine to actually be able to do the computation to display a JPEG. It was like a $4,000 card just to display the JPEG. And then to print it, the printers were $26,000 to print a photo, to get anything that didn't have big dots apart from each other. But the run-of-the-mill printing market, the average printer that people bought in the office was $500 or $600. As the market has changed over the years, there's still the mainstream printer is still $500 or $600, except that they can now do things like photo printing and all the things that were at the very high end. So what I'm sort of curious about for 3D printing is, are we looking at, and this is going back to the looking forward or getting a view of things in the future, are we looking at a situation where the $2,000 or $3,000 printer will still be the $2,000 or $3,000 printer, but it will just do a heck of a lot more things that now people are spending $20,000 to $100,000 on.
Right. So we very much believe that. I mean, we believe that the $3,000 desktop printer is capable of this much stuff today. And with materials development and software development and continued sort of tweaking and optimization of the hardware, it gets bigger and bigger and bigger. That we can meet the needs of more and more people, whether that's a wider range of material, and so there's new people in that bucket that couldn't print yesterday, or there's, I'll call it, thresholds of quality that we're now able to meet that we couldn't meet yesterday. And I think what we're excited about in this world of desktop 3D printing, in some ways, is we do a lot of our own development, certainly, but between the chemical companies and the plastics companies continuing to innovate on materials, and everybody piling in, from the BASFs to the DuPonts to the Eastmans to the Mitsubishis, all piling into this space. I think that's only good for us, only good for the customer. And I think it'll continue to sort of widen what that $3,000 printer can do.
I want to take this off to the side a little bit from what we're sort of planning on talking and ask you about the chemical companies and the plastic companies, because when we think about 3D printing, we're usually thinking about the mechanism companies. And we're not thinking about all of the sort of, chemistry class stuff. We're thinking about mechanical engineering and robotics and software design, and not plastics and chemicals and so forth. Can you give a rough insight into what that world is and what's happening and what's going on with those materials, and how does that affect you in terms of what you're able to push through an extruder or other technologies?
Yeah, I think we're just learning what the impact could be. For many years in 3D printing, if you go back to, again, 3D printing 1.0, 3D printing 2.0, all those companies, including the company that I used to work with, we all had a closed system. We had our own proprietary materials. We had our own team of scientists who developed materials. We were all, by definition, not very big companies. So it's not like we had hundreds of material scientists developing materials. We had 5 or 10. And I think the biggest of the companies in the space had 5 or 10. They didn't have 100. But as this has opened up now, and the big plastics companies and chemical companies have gotten involved, it just means there are now hundreds of people, maybe approaching 1,000 people, who are out there thinking about materials to be used on 3D printers. And I think just that critical mass will bring it. We've already seen it. I mean, we're printing polycarbonate and nylon and polypropylene on a $3,000 desktop 3D printer. And that wasn't happening 18 months ago.
Mm-hmm.
So I think all those things are accelerating very quickly. So that's good for Ultimaker. I think it's very good for the customer to have this huge range of choices. For the chemical companies and the plastics companies, they're listening to their main customers today. So if you're a big customer of a big plastics company, you make plastic things. So you buy tons and tons of plastic pellets from some of these big plastic manufacturers. You're starting to ask the question of them, like, we buy this grade and type of plastic material to make our toys or make our business equipment. Wouldn't it be great if we could have exactly that same material on our 3D printer? Well, the big plastics companies are uniquely able to do that, to be able to serve shipping train loads full of pellets for injection molding, and at the other side shipping the exact same filament out the door for the 3D printing market. So I think that will have a significant effect on quality and capability for the customer and for the whole industry.
And there's sort of a network effect, because the more 3D printers that are sold, the more opportunity there is for the chemical makers to do their own R&D, and the more that helps drive forward the printing market and the opportunities for what you can do with it.
Yeah, and what we've recently done, and what we're rolling out now in 2018, is what we call a materials developers kit. So it used to be that a few months ago, what most big plastics companies would need to do is they would need to buy an Ultimaker, and they need to buy some other brands of desktop 3D printers and try things out to really optimize their materials. And we've just decided, well, why don't we just try to shortcut that process, really hand them our recipe book in terms of the right profiles and settings and everything else, try to give them a 3 or 4 or 5 month head start. So it doesn't take that long to get things to the market. It gets things on the market faster. Again, it benefits the customer. It ultimately benefits us as well, because people will have more choices and buy more printers.
So that's kind of cool. It's like an SDK for chemists, which is pretty neat.
Yeah, for materials. Yep.
So the classic markets for 3D printing at the consumer level, anyway, have been making and prototyping. Do you see Ultimaker moving into full production, or do you see doing more specialized things like custom work in healthcare?
Yeah, so our vision of the world is that 3D printing, especially, we'll just talk about Ultimaker and our brand of or our sort of flavor of 3D printing. We think we're uniquely capable of doing prototyping, form and fit, jigs and fixtures and tools. And then when we think about full production, we often think that, and when we say full production, we also think volume production. We're not as bullish that 3D printing will sort of displace that in any significant way. I mean, once you get to hundreds of thousands or millions of the same part, the economics are pretty far away to be able to look at, is that capable? And perhaps there'll be other types of 3D printing technology, not FDM and not Ultimaker, that might better serve them. But what we see, but beyond that, we see the end of the product life cycle. We see things like spare parts. We see things like people retrofitting and doing different things or supplementing their product afterwards, where those tend to be lower volume custom applications. And we think FDM is actually uniquely suited for that.
Yeah.
And the way we think about that is, do we imagine, a big, million square foot factory with thousands of Ultimakers all next to each other making the same part? We don't think that's the future. But if you can think about distributed manufacturing and think about, let's say, an automotive brand, think about Toyota and the thousands of Toyota repair shops around the United States. Could we imagine a 3D printer in all those repair shops? Absolutely. And we think FDM, given its cost and ease of use and range of materials, may be uniquely suited for that type of application.
Yeah, definitely. This is a little fan controller for a very beloved fan that moves around and is quiet that I really like, and I lost the back piece of it, which I'm about to lose again. I lost this back piece of it and couldn't use the fan, and so it took me about 15 iterations, but I made one. And therefore, I was able to once again use the fan. And, I mean, granted, it was a little bit more work than it probably ought to have been, and I don't think everybody in everybody's home can do that. But I now have my beloved fan is working again because I could 3D print a very tiny detailed part.
Yeah, yeah. I mean, I think the ability to personalize, the ability to replace parts, I think is a big opportunity. And I think it'll all come down to how easy is it for people to do, how economical is it for people to do, and arguably we're sort of not quite there yet. Yeah. I mean, only people like you who do this, who are real enthusiasts and could know how to get there, do it. But the average person can't really do it today.
Yeah, yeah. In fact, that's where I was going next. Is personally, what's really excited me about this is the ability to make custom objects that are just uniquely tailored to my personal or specific needs. And that's not just home needs. That's for custom things I need in the studio or custom things I need in the workshop, but really unique to the problem I'm trying to solve. And they wouldn't be much use for anyone else. And I've never had the capability for that. I'm a software guy, so the ability to actually make something is very unique to me. It's usually I just if it's physical before this, I haven't been able to make it. I've just been like, okay, duct tape, and if I can't use duct tape, there's no answer for it, And now I have all these very specialized things that I'm able to use. But are you seeing a growth in people realizing they can make these truly custom solutions, or do you think the 3D modeling barrier of entry is really too challenging for most buyers?
Yeah, I think there's a growth. There's a growth certainly that people have embraced 3D printing for doing some custom stuff. But that modeling barrier is still there. And we think it's, I think going forward, for this truly to be a tool that people could really use in their own home setting and be able to do the things they want to do, I think there'll have to be changes with the software to allow people to more easily do things. And what we've seen is the places where that's been successful in certain verticals is when there has been a customized CAD solution that's very specific to a certain type of hobby or part. So I'll use an example: the jewelry market. So actually, the jewelry market is been a relatively early adopter with 3D printing. So professional jewelers and jewelry factors came to 3D printing pretty early, mainly because a couple of reasons. One, jewelry is a product that's often customized. Two, it's relatively high value. People pay a lot of money for things and appreciate customization. But jewelers were not, even the most sophisticated of jewelers were not capable of taking a seat of SolidWorks and designing a piece of jewelry. It's just not suited for that. So a product was developed in Asia. This goes back about more than 10 years, called JewelCAD. So there's actually a product called JewelCAD. So it is a CAD package specifically for jewelers that has all the templates and the things you select to be able to create jewelry. Well, that was a case where an industry found a CAD solution specific to them. So you can imagine in the future, shoe CAD and toy CAD and a furniture CAD and a whole bunch of other things to make it easy. Because if most customers have to start from scratch, uh, designing the cube or designing the circle or designing it just doesn't make a whole lot of sense.
Yeah.
And I think you'll see more and more customized vertical CAD packages in specific for specific industries and specific applications.
Yeah, that makes sense. I'm something that most of our listeners don't know is that my dad was a jeweler and his dad
Okay.
was a jeweler in Manhattan. And so, yeah, I grew up with these little watching these little tiny workbenches with these little tiny little things, and they would hand file the parts. And I mean, this was old country jewelry making. I mean,
Yeah.
there was not a bit of technology. Although my father was fascinated by the technology. He never could quite grasp the intuitiveness of it, but I could see definitely something that a part that determines how many pieces hold a stone, and okay, you have a stone with 5 ends or a stone with 8 ends, and you type the number in, and poof, it makes that piece.
Yeah.
And I
Yeah.
can certainly
Exactly.
see that.
Yeah. I mean, there's another reason I brought up some reasons earlier why jewelry was gravitated toward 3D printing quickly. The third reason, which was probably in some ways the most important, is that the traditional way of making jewelry by hand takes a long time
Hmm.
and requires a lot of skilled people. So if you had a technology way to do it faster and less expensively, then that was obvious. And that's why I think that's moved into that market perhaps faster than others.
And so that brings me to one of the questions that I was planning on asking, which is what about metal? Because, certainly that jewelry market is all about the metals and the stones. When are individual makers and designers going to be able to print actual full metal objects that are as strong as, say, a shelf bracket or as fine as, a gold or platinum ring?
Yeah, so most of the applications in jewelry today, the end product is metal, right? So what's being printed is typically the pattern, the wax pattern that's then cast.
Oh, really? Okay.
So that's what's usually people aren't printing metal; they're printing the wax. The same way your father or his colleagues worked and sculpted the wax, and
Uh
then they
huh.
put it on a tree, and then they cast it in whatever metal they were looking at.
After my
So
after my dad passed away, we cleaned out a storage cabinet and we found thousands of these wax forms
yeah,
that were two-sided wax forms that fit each of their pieces of their jewelry. And
yep,
yeah, they were hand done and hand casted, and that's so
yep.
that part you could print out of either like a flexible material, I guess, or a
Yeah,
solid
so that's
material.
that's been true for a while. So the ability to print patterns. So whether you're doing that on a $100,000 machine or a $3,000 machine, that ability to print patterns that you typically then burn out or melt out, that capability has been around for a long time and is used in jewelry. It's used for other sort of precision cast parts. Um, golf clubs are actually a pretty good example. Golf club
Really?
heads. A lot of the golf club manufacturers have 3D printers, and then they print the pattern, and then they cast the prototypes. In production, they do it a different way because that's a sort of a high volume business. But that's been going on for a long time. What's been happening recently, though, is more and more technology starting to be available to do direct metal. So instead of printing the pattern, you're actually printing directly the metal. And those technologies, there's been a number of technologies that have been around for 15 or 20 years, um, but they're pretty expensive. So these are machines that use a powdered metal material and lasers or an electron beam and print parts for the orthopedic implant market, for the aerospace market, for high value markets that really value a customized, optimized part. But that's still in the range of hundreds of thousands of dollars for a 3D printer. There's some new entrants in the market that have shown up in the last year or so. One, a company called Desktop Metal, and another company called Markforged. Now they have $100,000 solution. So in some ways, I'm thinking back to the plastic market where in the 90s it was hundreds of thousands of dollars, and then the 2000 decade it was tens of thousands of dollars, and now it's single-digit thousands. Perhaps metal is 10 years behind in that curve, and I think the market will decide how much people prioritize metal, how much people need metal, whether it's for prototypes or end-use parts.
Cool. So you're an FDM, a fused deposition modeling producer, right? Where do you see the other technologies like SLA and now the Ultimaker 3 does two filaments, so it can do two colors and it can do
That's
supports and non-supports are dissolving material and a regular material. But where do you see things like SLA and full color fitting in for both individual makers and for Ultimaker?
Yeah, so not sure if Ultimaker, I mean, what our core technology and how we think about the world does revolve around FDM. And so when we think about our future and our past, we more than likely will be designing our systems around FDM. But certainly, there is a market for SLA technologies. I mean, SLA technologies bring a range of benefits that at least at present are out of reach for FDM. There are some full color technologies that have been out there for a long time that still bring a lot of value. And so I think I don't think there will be any one winner in terms of the core technology. All the different methods, whether it's FDM or SLA or using sintering powder or those other methods, they all have their unique strengths and weaknesses, and therefore they tend to be absorbed or adopted by the customers that value those strengths.
So what about time to object? Some items I've printed have taken 3, 4, or even 5 days, and at any time a single glitch might require the print to start over. Although I got to be fair, that's never happened with the Ultimaker prints. Are we going to see fatter nozzle sizes to reduce printing time, or can physics handle the speeding up of the actual deposition and cooling speed and the inertia involved?
Yeah. So to answer that question, all those things are being worked on. So there are bigger nozzles, allows faster deposition of material. You're giving something up typically, though. You're giving up resolution. Same thing like in 2D printing when you have larger pixels, you can print faster, but you give up some resolution. So that's been well established and is available on the market today. What is interesting, though, is there's more and more work. We're doing work, and some of our partners and competitors are doing work in really trying to optimize the filament handling. You got to be able to feed the filament fast enough so that you're not tearing up the machine or tearing up the filament. So that's one part of the problem. You got to be able to melt it fast enough. So you got to be able to put enough energy into that part to be able to melt it fast enough. And probably in some ways, the most important thing is you got to be able to cool it fast enough. So that's why you actually don't see today. You don't really see FDM solutions with 10 nozzles all spitting out plastic at the same time.
Mm-hmm.
It's not that you can't do it. It's just then you'd have a big blob of plastic.
Yeah.
And so I think there's a bunch of work being done that I think that is very promising. That I think we all can sort of confidently see that by optimizing all those parameters, we could probably get to a 5 or 10x difference in terms of total speed for FDM. The software piece is also driving this. Is that the algorithms to think about slicing and tool paths and putting down more or less material in different parts of the part, that's also happening very quickly. And I think that'll help really drive not only the part quality, but speed.
Now Ultimaker is the author of Cura, right? So you guys have been really generous in making that available.
Yeah, so we're the author is a good word. We don't say owner necessarily. We're the curator of Cura. So because Cura is open source, but safe to say we spend most of our guys are doing most of the work out there in the world. And we've seen significant advances. We're happy to be able to do it and offer to our customers significant advances in Cura especially over the last 18 months. So it can go faster and faster and faster, and people can have more choices about how to build their part.
Yeah, it's also kind of interesting because Cura is used by a lot of your competitors as well, and you've been very generous in supporting that ability for others to do their thing, and I guess that means you're confident in your market to be able to do that.
Yeah, I mean, yeah, sure. There are times where we sit around the table and say we're enabling all of our competitors here, but I think in the big scheme of things, it's helped stimulate the market. It's helped drive demand for FDM. It's helped make FDM probably the number one choice for most users for desktop printing. We believe actually Cura and Ultimakers together is the best solution. And so there's a few things in Cura. We actually just came out with a product called Cura Connect, which is a networking tool, but that really only works on the Ultimaker for now. We'll continue to make that open source, but we'll continue to work on trying to make it work the best with Ultimakers.
Now, are your printers also open source?
They are. Yep.
Cool. So I have 2 questions left, and then I'll thank you for volunteering all your time today. The second to last question is, what are the 3 absolutely coolest things ever made with an Ultimaker printer?
Yeah. So I thought about that question a little bit. I think it's I group this into 3 categories. So one is the fact that desktop printers can now print really end-use parts, be good enough for end-use parts. And so we actually have a case study on our website from a company called Tucci Hot Rods. It's a sort of custom automotive hot rod shop, and there's lots of sort of vents and pieces on the dash that are beautiful plastic pieces that were printed on an Ultimaker. So people think about desktop printing and they think about lots of little small plastic stuff. But in this case, they were using a desktop printer to put parts on a car and run it. But I think that's number
cool.
1.
Yeah.
2, you get to the medical market. I mean, doing prosthetics, especially in third world countries where there's not a lot of resources. There's organizations like Enable and LimForge that for the first time, desktop printers were now accessible, affordable, and allow people to do these things. There's lots of stories out there of parents buying a 3D printer and then actually developing their own aid or prosthetic for their own child, where the healthcare system, whatever country you're in, is not the easiest to deal with, and they just did it themselves.
That's amazing.
And so I think we get a charge out of that. And I think the last one is in education. So the fact that the price has come down, it's easy to use, and now it used to be that the first 3D printers going back 10 or 15 years ago in education meant that it was at the mechanical engineering department of a major research university, and now it means it could be in a second grade classroom. So I think the ability for even if it's just little toys, it's allowing kids to be able to learn and think and be creative, and so I think that's the third category that we get the most charge about.
That's pretty amazing. Okay, so my last question is, did I miss any questions I should have asked? Is there anything you want to tell all those folks out there that about Ultimaker, about yourself, or anything that you'd want to share?
No, I think I think the thing that we think most about as a company, and we think is going to be the most important for our customers and helping us grow the market, is thinking about the total solution. So we did an interview a couple years ago. I didn't do the interview. One of my colleagues did the interview, and they talked about the difference between being the champion of the spec sheet, of trying to have all the latest and greatest specs, or the layer thicknesses, or the temperatures, and everybody's in a race for the spec sheet, of being the champion of the spec sheet. And we think about it differently. We try to be the champion of the workflow, and that's why having Cura, or being the author and custodian of Cura, helps us do that. So at the end of the day, what we care most about is not necessarily what specs are exactly the latest and greatest, but what's the best sort of total solution for the customer. Because we still think in a lot of ways the barrier for use is not part quality, and it's not speed. I mean, those are all barriers, but I think the biggest barrier is ease of use. I mean, at the end of the day, what do people want? People want to be able to walk up to the 3D printer. They want to be able to take their iPhone. They want to send the file to the 3D printer. It prints it. It pops it out, rolls out on the floor, and you pick it up. And that's sort of what they want. And we're not there yet.
Yeah, and you want to picture something in your head and go, okay, I have this picture in my head. I need it tomorrow.
Or I need it in an hour.
Yeah.
Half an hour. and when it's done, a bell goes off, and it's right there, and you pick it up.
Yep.
And we're not there yet. And so I think that's what we think about most when we're thinking about our technology and addressing the market.
Well, awesome. John, I really, really appreciate your time today, and I'm sure everybody who's listening and watching will as well. Thank you for coming by, and thank you for sharing so much. And we'll continue to watch Ultimaker and look forward to all the new stuff coming out.